Just like there's beauty in the extents of the universe, there's amazing beauty in symmetry. The smaller you go, to more atomic levels. The Microsystems program here at the University of Utah is doing groundbreaking research in MEMS and nanotechnology. MEMS are microelectromechanical systems. Many devices nowadays are already beginning to employ MEMS, like your airbag in your car, the accelerometer that senses when you have a crash. Your Wii device, your iPod, they're built using the same microfabrication technology that we use here. There's a huge demand for microsystems designers, people who know how to make computer chips or MEMS chips. Students, when they first come to the University of Utah, typically don't know very much about the small devices. They're thinking big engineering projects, and they start taking classes and getting more interested in that.
I did choose the university because I noticed that they had a great engineering program. I especially enjoy combining the artistic applications of it. I was offered a position here in the lab as a freshman. Before I knew it, the next semester I was down in New Mexico presenting our research, and then a year later in Berlin. When I'm shooting electrons, which are negatively charged, at my sample, I'm having two different surfaces that are negative. And a result of that is that the two repel from the chip. Here we have a grizzly bear. Right now it's flat. By adjusting the voltage a little bit, I can get it to pop up off the chip for you. Maybe some people might think they're a little trivial, but actually we find out new things that we wouldn't have found out otherwise, I don't think.
The first design I did was Leonardo da Vinci, the mechanical lion. People have made actual replicas of this lion, but they've had problems with gravity and friction. I decided to use this design in a MEMS, in a micro scale of it, where the gravity and the friction doesn't really apply there. In the animation I decided to make, everything is exactly right, so it would rotate how it should. I've been the first person to have Leonardo da Vinci and have that attached to MEMS. There are many who are fascinated to see what I have done, the work that I've done, so I just want to thank my teachers for giving me the opportunity.
The chips that we've designed couple this microengineering and the artistic side and the creative side of these students, and it's really gotten them to think outside of the box. What's just a practical application versus what can we make look really neat and appeal to people that just aren't technologically oriented, that will draw them into the program and help them see that there's more applications to this than just your accelerometer and your Wii. We have several companies here in Utah that manufacture these chips, and just about everyone we can graduate can get a job at one of these companies.
All the teachers here were very willing and helpful to work with me. They never looked down upon me and saw my deafness as something like a disability preventing me of doing things. They never did that to me, and I was able to excel and succeed here at the University of Utah.
We're one of the few colleges in the nation that have this sort of program that deals with MEMS. You can start as early as freshman, really, first day in, and before you know it, all this great stuff can happen to you too.